Welcome to Ask and Learn.
In this problem, we want to show that given f of x is equal to x cubed plus 1 over x, that first, the limit as x approaches plus or minus infinity of f of x minus x squared is equal to 0. And what this will show us is that on either side of our graph, it's going to approach the same shape as x squared. And then we're going to use this fact to help us graph our function f of x. All right. So first, let's just go ahead and find what f of x minus x squared is. So let's do that first, since we're going to need to use it for two limits. So we go ahead and plug in x cubed plus 1 all over x minus x squared. We'd go ahead and get a common denominator here by multiplying this by x. That would give us x cubed. Then we'd have x cubed plus 1 minus x cubed all over x. The x cubes cancel here. And then we're left with 1 over x. So if we come over here to this limit that we're trying to find, so first just the limit as x approaches infinity of f of x minus x squared, which ended up just being 1 over x. Well, we know that goes to 0. And then likewise, the limit as this approaches negative infinity would also go to 0 as well. So we now have this, which shows that when we go to graph this, it'll have the same end behavior as x squared. So I went ahead and made a graph of x squared really quickly, just so when we are graphing this, we will be able to just kind of follow it really closely. Now, the other things that might be of interest, at least since we're just sketching it, is we'd want to say where our intercepts are going to be and any horizontal asymptotes we're going to have. Well, vertical asymptotes, because we already know we're going to have no horizontal because the end behavior follows closely to x squared. So to find our intercepts, so let's go ahead and do the x-intercepts. So remember, we set f of x equal to 0. So x-intercept. So we have f of x is equal to 0, which means we have x cubed plus 1 over x equal to 0. Then we would just set the numerator equal to 0, subtract 1. Then we would take the cube root on each side. The cube root of -1 is just going to be -1, so we have x is equal to -1 for one of our roots. So let's go ahead and plot that point. So we're right there. Next, we should find our vertical asymptote. So remember, for vertical asymptotes, we just set the denominator equal to 0. So vertical asymptote, well, that would just be x is equal to 0, since that's the only thing we have in our denominator. So let's go ahead and put that down. And now we need to decide if we're going to be on the right or the left of this function. So we can go ahead and take the limit as x approaches 0 from the right of x cubed plus 1 all over x. So plugging this in here, we would end up with, so 0 from the right cubed plus 1 all over 0 from the right. And now something from the right is going to be positive if we cube it. So that's still going to be 0 from the right plus 1 all over still something 0 from the right. So adding something coming from the right of 0 and 1 would just give 1. So we have 1 over 0 from the right. And so that would go to positive infinity. So we know our function should start coming up like this here. And since this vertical asymptote is like 1 over x, we know that the limit on the other side, as we approach 0 from the left, should be over here where it starts. So that means, at least on the right, it'll look something kind of like this. So it's going to dip down, and then at some point, let me draw that a little bit better. So it's going to dip down and then come back up at some point, and then it'll start following x squared really closely. And then on this other side, we're going to come up from negative infinity. We're going to have to cross our x-intercept, and then we're going to get very close to x squared, and then just follow this out to infinity. So this is how we could go ahead and use that this function approaches essentially the same as x squared to go ahead and get a nice sketch of this graph.